Welcome to the DIY Honda Garage channel. The Diagnostic Trouble Code, DTC P2101, indicates an Electronic Throttle Control System, ETCS, malfunction in the 2011 to 2015 Honda Civic. The ETCS is a critical component responsible for controlling the throttle valve's position, which in turn regulates the air intake to the engine, significantly impacting engine performance and vehicle acceleration. This system is electronically controlled, meaning it relies on various sensors to communicate throttle position, engine speed, and vehicle speed to the Engine Control Module, ECM. The throttle body is typically located between the air intake and the engine, making it easily accessible for testing and diagnostics. A malfunction here can compromise vehicle safety and efficiency, necessitating immediate attention. The Electronic Throttle Control System, ETCS, governs the throttle body to regulate airflow into the engine. The throttle body itself contains a throttle valve that opens and closes to manage the air intake based on the driver's input via the accelerator pedal. The ECM processes signals from various sensors to determine the appropriate throttle position. The throttle body is typically mounted on the intake manifold, hence it can be accessed easily during diagnostics. The ECM, which is situated near the firewall under the hood, ensures proper communication between sensors and the throttle actuator, maintaining optimal engine performance. If there is a malfunction in this system, as indicated by DTC P2101, various engine performance issues can ensue. Several factors can lead to the appearance of DTC P2101. A faulty throttle body is a primary suspect. Wear or debris may hinder the throttle valve's operation, causing miscommunication in throttle position control. Loose connections or poor wiring between the throttle body and the ECM may cause intermittent signals, leading to the malfunction. Additionally, if the ECM isn't functioning correctly or lacks the latest software updates, it can misinterpret the data it receives, resulting in erratic throttle behavior. Each of these elements impacts the efficacy of the ETCS, and thorough inspection is necessary to determine the root cause. When DTC P2101 is present, drivers may experience noticeable symptoms affecting vehicle operation. A significant loss of acceleration may occur, where the engine may not respond effectively to throttle input. This could manifest as engine surging or unexpected drops in power while driving. Furthermore, the check engine light will illuminate, notifying drivers of underlying system malfunctions. Other symptoms may include erratic engine speed, where the engine RPM fluctuates despite constant pedal pressure, creating an unsafe driving condition. Recognizing these issues early can help prevent further complications. The first step in troubleshooting DTC P2101 involves performing an ETCS system check. Start by turning the ignition switch to the on or to position. This powers up the vehicle's systems without starting the engine. Next, clear the DTC using the Honda Diagnostic System, HDS, ensuring that you have a fresh starting point for the troubleshooting process. After clearing the code, execute the ETCS test available in the HDS, which tests the system's functionality and checks for any immediate faults. Following this, you should examine any pending or confirmed DTCs that might still exist. If DTC P2101 is indicated post-test, it confirms a malfunction in the ETCS that warrants further inspection. Step 2 involves verifying the problem through real-world operation. Take the vehicle for a test drive, allowing it to run for several minutes, which helps gather data under normal operating conditions. During this drive, focus on the freeze data parameters, engine speed, vehicle speed, and accelerator pedal position sensor readings. After completing the drive, connect the HDS again to check for any pending or confirmed DTCs. If DTC P2101 is indicated once more, the issue is likely consistent and requires deeper investigation. However, if the code does not appear, it may suggest an intermittent failure, prompting you to inspect related wiring and connectors for any faults. In the third troubleshooting step, you'll begin identifying the possible failure points, notably the throttle body. Start by turning the ignition switch to the lock 0 position for safety, before disconnecting the intake air duct from the throttle body. Once the duct is removed, turn the ignition switch to the on 2 position again, and clear the DTC using the HDS. Next, examine the throttle valve operation by executing the ETCS test through the HDS. Observe its movement. It should operate smoothly and without hesitation. If the throttle valve is operating correctly and DTC P2101 does not appear, clean the throttle body and conduct a repair verification. If issues persist, follow up with the next troubleshooting step. Step 4 focuses on checking for open wires in the MTR1 and NTR2 lines, which are critical for throttle body operation. Begin by turning the ignition switch to the lock 0 position. Utilize the HDS to jump the SCS line, then disconnect the ECM connector C49P and the throttle body 6P connector to facilitate isolation of the circuit. Use a jumper wire to connect the appropriate terminals A and B in the throttle body connector. Finally, check for continuity between the specified test points in the ECM connector while both connectors remain disconnected. Continuity between these points indicates the MTR1 and NTR2 wires are functioning correctly. If not, there may be an open circuit requiring repair. The final troubleshooting step involves examining the throttle body's internal circuits for proper resistance. Start by disconnecting the throttle body 6P connector. With the ignition in the lock 0 position and the ECM connector still disconnected, measure the resistance between the two test points on the throttle body side. You are looking for resistance of about 1.0 kilo-ohm or greater, indicating a healthy circuit. If this resistance is present, replace the throttle body, as it is likely faulty. Conversely, if the circuit shows expected values, the issue may lie with an outdated ECM. Updating the ECM software or substituting a known good unit may resolve the fault. Follow this up with repair verification. Upon completing repairs related to DTC P2101, it's crucial to execute a thorough repair verification process. Start by reconnecting all connectors that were previously disconnected during diagnostics and repairs. Next, turn the ignition switch to the on 2 position and reset the ECM using the HDS. Following the reset, perform the ECM idle learn procedure, which helps the system relearn optimal idle settings for the engine. After completing these steps, take the vehicle for another test drive within the ranges of the previously recorded freeze data parameters, paying close attention to engine performance. After the drive, once again check for any pending or confirmed DTCs, confirming that the issue is resolved. To prevent future occurrences of DTC P2101, establish a routine maintenance schedule that includes regular cleaning of the throttle body. Deposits can build up and adversely affect performance, so maintaining its cleanliness is vital. Additionally, routinely check all connections and wiring associated with the throttle body and the ECM. Ensure they are secure and free from corrosion or any damage. Promptly addressing any wiring issues will eliminate potential intermittent faults that might lead to DTCs. Lastly, ensure the ECM is updated with the latest software to improve system performance and reliability. This proactive approach will enhance your vehicle's longevity and operational efficiency. In conclusion, DTC P2101 signifies a malfunction in the Electronic Throttle Control System, demanding immediate attention to maintain safe driving conditions. Thorough diagnostics are essential to determine the exact source of the issue. Following the outlined steps methodically ensures all potential faults are assessed correctly. Understanding the relationship between components like the throttle body and ECM within the system is crucial for effective troubleshooting. Moreover, preventive maintenance practices, such as cleaning and regular checks, contribute significantly to reducing the likelihood of encountering similar issues in the future. Keeping your Honda Civic in top shape not only helps avoid costly repairs, but also enhances overall vehicle longevity and performance. Please like and subscribe to the channel. See you next time.